All right, here we go. Starting out chapter 4, you can see we have radian and degree measure. This is where we really get into the nitty-gritty of trigonometry, and we get into the heart of what's going to be the unit circle, which we'll introduce on this video. On this video, I'm going to go over just the front side of the notes, and the back side where it has converting between radians and degrees. We'll do that in class. Okay, it's real important to understand these 4 definitions. I already have them listed, at least for 2, 3, and 4, so you can write those down right now. And it's really what we're going to deal with. We're going to take angles, okay? And we deal with the degree measure, which you've dealt with. You know how to deal with degrees. We're going to relate it to something new that's called radian measure, okay? Obviously, it has to do with the radius of a circle. Now, it's real important to understand how we measure angles in the coordinate plane. Now, when we measure angles in the coordinate plane, the positive part of the x-axis, this is called the initial side. This is where you always start with an angle. Every single angle in the coordinate plane, whether if we measure it with a positive degree measure or a negative degree measure, it always has that initial side as one of the segments there. Now, to get the other side of the angle, let's say I did this. Let's say I put this here. Okay, let's say this is angle theta. This side right here, this is called the terminal side. Okay, basically where the angle ends. That's why it's terminal. Okay, and the measure between the initial side and the terminal side, the rotation there, that gives us the degree measure. Now I know if I start at the initial side and if I go all the way around, I have a circle, and I know in a circle that's 360 degrees, which is what we're really going to use here. Okay, 1 revolution is 360 degrees. Okay, now positive angles, let's move on to second definition. This is real important. You always measure it from the initial side and you go counterclockwise. So if I look at the example that I have here, I start here at the initial side and I go from here to the terminal side. This angle measure is going to be positive because I'm going counterclockwise. I'm just going to say, just for this example, I'm going to say theta is 45 degrees. Okay? The other way of looking at it, I could go the other way. I'll put this in green. If I look at this example, I'm going to start here at the initial side. Okay, let's get rid of that. Let's say I start here at the initial side, but let's say I go to the terminal side, but I go the other way. I go clockwise, which is going to be negative. If I go clockwise, okay, I'm going to go negative. Now, if I go down, this is going to be 90 degrees. This is going to be negative 90. This is going to be negative 180. This is going to be negative 270. And I have to go another 45 degrees. So if I add 45 to that 270, I get, what is it, 315? So according to this same angle, it's negative 315 degrees. All right, these look different right here, but what I just went over, this leads to the fourth definition. These are coterminal angles. These are 2 angles that they have the same terminal side. Every single angle always has the same initial side, but you might have the same terminal side, but you can measure them many different ways. You know, I could go from here to here. This is positive 45, or if I go from here to here, this gives me this, negative 315 degrees. Or I could keep going around and around and around, and I'll still end up at the same point. Okay? So many different ways to represent degree measures. It could be positive if I go counterclockwise, or negative if I go clockwise. All right, let's relate this. Now, the degree measure, kind of a good word I like to use for degree measure, and you kind of don't think of it. What degrees measure is the rotation. How many times do you rotate? If you go all the way around and make a circle, it's 360 degrees. Now I'm going to relate this to radian measure. Okay, let's go down here for radian measure. Okay, real important to understand this definition. And we're going to do an activity in class that really goes over, gives you a really kind of hands-on experience to understand radians, because sometimes it's difficult to understand because we're so used to dealing with degrees. All right, for radians, now what a radian means is it measures the arc S that intercepts the measure of a central angle. We'll say the central angle is theta. So I'll put that in there. Let's look over at this beautiful circle that I drew here, this blue circle right here. This is probably a formula. I don't know if you remember, you dealt with this formula in geometry. This S is basically the arc that the central angle intercepts. I know R is going to be the radius, and this theta, well, that's the angle. Now, I know theta, usually that's in degrees. This deals with the rotation from here to here. Well, we're also going to relate it to S. This is basically going to give us our radian measure. It basically gives us the arc. The measure of this arc, we're going to relate that to the measure of this angle in degrees. And we're really going to kind of use those hand in hand. They're going to correspond to each other. Now, if I kind of go over this, I know, let's relate this radian. Since I'm dealing with an arc, since I'm dealing with the outside of the circle, what I'm really dealing with is the circumference. So I want to put C for circumference. Now, if you remember, the circumference formula is 2 pi r. That gives us the distance all the way around the circle. And I know that r is the radius. Now, I'm going to lead this into the unit circle. You're going to see, like, the next 2 months, this is all you're going to deal with is the unit circle. And this is the very beginning of the unit circle. I can't contain my excitement right now. All right, the unit circle. Here's the main thing. Why is it called the unit circle? Well, we look at a circle, but specifically for a unit circle, r has to be 1. The radius has to be 1. So if I plug in 1 to this formula right there, if I do 2 pi times 1, the circumference for the unit circle is 2 pi. So if you go 1 revolution, the circumference or the distance or the arc, the whole circle, is 2 pi. I'm going to put this right here. So I'm going to do 1 revolution. If I go all the way around in the unit circle, that's 2 pi. I'll put r, meaning radians. Degrees, I know if I go all the way around, that's easy. It's 360 degrees. So I'm going to relate these. Let's draw an arrow. So if we say, all right, 360 degrees, you know you went 1 revolution. If we say we're dealing with 2 pi radians, same thing. We're doing 1 revolution. That's just the distance around the circle. Okay, let's relate the rest. Let's say you go half a revolution. Well, it's easy in degrees. If I go half a revolution, half of 360 is 180 degrees. If I do that in radians, well, half of 2 pi is just pi. So we'll say pi r or pi radians. Let's say we do a quarter. If I go quarter of a revolution, well, a quarter of 360 degrees, that's 90 degrees. And if I take a quarter of 2 pi, if I did this, 2 pi, if I take a quarter of it, it's the same as dividing it by 4. Well, that reduces to pi over 2. So that's pi over 2 radians. And then if I did 3/4 of a revolution, well, you can see you're just going up by 90. So if I did 3/4, or if I did 3/4 of 360, if I multiplied that out, that would give me 270 degrees. Okay? And if I did the same thing, if I did 3/4 of a full revolution in radians, if I did 3/4 times 2 pi, let's see here, that would give me 6 pi over 4, which reduces to 3 pi over 2 radians. So I'll put r for radians. So this is the main point right here, is to be able to look at these and know, all right, 360 degrees, that's the same as 2 pi radians. 90 degrees, that's the same as pi over 2 radians. The radians, it's a little weird, it's a little different dealing with, but you're going to see as we do this over and over and over again, it's going to be automatic. Okay? So we'll just do that part, and then we will convert. We kind of already started to convert between degrees and radians, but we'll look at other angle measures, you know, maybe like 100 degrees or 150 degrees, and we will convert that to radians and other way around. Okay? So that's the first part. Tomorrow, we'll convert degrees and radians.